like 40 seconds.
Wow.
40 seconds.
Oh my god.
Oh my god.
Oh my god.
33.
Wow. Awesome.
Oh my god. Wow! 20 seconds!
Oh, I got Corona. I've got Corona.
Yeah?
I have Corona.
Yeah? There it is!
The reflection on the water!
10 seconds! Woo!
Diamond ring!
Diamond ring!
Diamond ring! Look! Oh my god! Whoa! My god! Look! Providence!
Wow! Woo! Oh my god! Whoa! Woo!
Check that out.
Woo! Wow!
Look at it. Oh, look at the cone of the shadow. See? Look at this. This is the shadow. Like this. Look at that, man.
Whoa! Look at that! Oh my god! Wow! Look at that, man! Oh my god! Is that beautiful or what? I gotta take photos here.
Just incredible.
Right? Take your time, Luke. Take your time. There's lots of time. Lots of time to look at it.
Look at how gorgeous it is. Look at the sky. Look at the sky.
I know. Look at that.
Look at the umbra.
Yeah, you can
Look at the
see it.
umbra.
Yeah, it's it. Yeah. Yeah, I see it. Yeah. Wow.
Oh, look, that's a cool Corona, man. Look at it shooting off like that. Right above the,
Yeah.
Oh, that's so killer.
Wow. Oh my god. Look at it. Wow. Oh my god, that's so beautiful. Look at that. That is so beautiful. Now go up a little bit. Yeah. Go up a little bit. Oh, wow. Oh, wow. My battery died, but whatever. Dave, you want to look through?
Yeah.
Here, real quick. Yeah, go ahead. Go ahead. Focus is on the. Oh my God! Look how long. Like we got.
Oh, that's so sweet. Look at the prominences. Killer Corona. Oh man, that's so nice. Oh, look at the prominences in the bottom.
Yeah.
Right about 6
I
o'clock.
see it.
Quick look, quick.
Wow. Oh, is that the diamond ring? Whoa!
Don't look anymore.
Wow! I'm just
Look at the umber going that way.
You can see it. Yeah. You can see it.
Look at the whole shadow moving this way.
Yeah. Wow! Oh wow! Look at that! Oh my God! That was...
Many of you are already acquainted with my zigzag argument. There are many apologetic as well as debunking attempts in the form of YouTube videos, which you can easily find by typing in YouTube or Google search engine zigzag argument. I uploaded a few years ago on my secondary channel a video by the name Zigzag Argument for Dummies, in which I interpreted my own argument. So if you are interested, you can easily find it on YouTube. I would also suggest to see my, for everyone who is interested, to see my final word on this by watching video which I uploaded by the name Zigzag Argument is the Winner. Zigzag Argument is the winner. Although there are certain problems with this method of verification, I would call zigzag argument a method of verification. Principally, This argument is quite correct, and we can use it either to prove or disprove heliocentric theory. The core of my argument is this. If we are on a rotating globe, first half of one Arctic day, polar day, when the sun is 24 hours above the horizon, we are rotating from right to left, from east to west. And the second half of the day, we are rotating from left to the right, which is again same direction, west-east. During the second part of the day, we are watching the sun across the North Pole. And during the first half of the day, North Pole was behind our backs. Now, another idea how to verify whether we are rotating or we are at rest would be if we could ensure somehow lateral displacement on a rotating Earth. Of course, we would presume that we are moving laterally or that we are rotating, and then we could come up with an idea how to transform this rotational movement into lateral displacement. And that idea is to focus the sun, which is presumably stationary, all the time. While we are focusing the sun, although we are rotating, for all intents and purposes, we are practically moving laterally. We should focus the very center of the sun, and that center shouldn't be larger than the total amount of our lateral displacement. If we used, for example, a directional gyro, which is a geocentric proof in itself, then all this thing would be totally superfluous. Since when we direct directional gyro into the sun, as soon as the sun would move for any amount to the right, directional gyro would indicate that the sun moved and we stayed at rest. If we use directional gyro so that we could ensure our lateral movement in this hypothetical situation, then we could tell that the very center of the sun moved to the right as we traversed this line to the left, and vice versa. When we moved from left to right, the very center of the sun would be moved to the left. And that would be one possible method of application of our zigzag argument. I would like to present you another method of usage of our zigzag argument. In our scale-down model, this disk represents 12.8 thousand kilometers, which is the diameter of equator, and this little circle in the middle represents our Arctic Circle. Within heliocentric model, the distance from this little disk to the moon, which represents this little thing, is 3.7 meters, and the diameter of the moon is represented by 3.5 centimeters. The sun in this model would be about 1 mile distant from this little disk, and the diameter of the sun would be 14 meters. In heliocentric model, the moon is moving across the sky 3,500 meters per hour, which is about equivalence of its own diameter. One diameter of the moon per hour to the left in the same direction of Earth's rotation. Since the sun is so far away and so big, all rays of the sun are parallel. Since the moon travels very slowly in heliocentric model, so even if we can show you here 3.7 meters distance, but geometrically it is almost the same, because the rays of the sun are parallel, and at 3.7 meters the same consequences would be regarding the direction of moon's shadow, which is cast on the surface of the Earth. So the moon is at 11 a.m. If we think about a scenario in which solar eclipse occurs at noon, noon would be here, 11 a.m. would be here for our observer at noon position. Noon and 1 p.m. would be here. For our guy who is on the other side of Arctic Circle, 11 p.m. would be here, midnight would be here, and 1 a.m. would be here. So, in geocentric scenario, let's say that the moon is at the same distance, but this time the moon would be in this direction, 3.7 meters, at 1 p.m. for the observer at noon position, and at 11 a.m. the moon would be in this direction, 3.7 meters. So the moon would move in these 2 hours 58 diameters, and in geocentric scenario these guys are at rest and the moon moves in arc 58 diameters at about 100,000 kilometers per hour. And in heliocentric model, moon moves in the opposite direction with respect to the heliocentric model, and much slower. Its speed is, as I said, about 3,600 kilometers per hour, which is roughly its own diameter. In heliocentric model, at 11 a.m. for this guy or 11 p.m. for this guy, the moon is here. Now the moon comes here right at noon for this guy and midnight for this guy, and then proceeds further to the left. The line of intersection is somewhere here, because total eclipse is at noon or at midnight, depends from which point of view we are observing it. So, since this guy is moving in the same direction as the moon and this guy is moving in the opposite direction, the result of the speed of the moon, or of the speed of moon's shadow, would be we should subtract the speed of this guy on the rotating Earth from the speed of the moon, and for this guy we should add his speed to the speed of the moon. So we would have a pretty different speed of the moon, and I would like to see one peer review document in which some scientist would elaborate on this. Until this day, there isn't one single proof in favor of Earth's rotation or Earth's orbital movement. This is perfect opportunity for scientists to show us that simple proof, because this would be very simple to examine this situation and to conduct one experimental observation. and which would be corroborated with mathematical calculations. Until this day, such thing doesn't exist. They are not interested in debunking themselves. In geocentric model, this transition of the shadow of the moon is kurac jebeni mater. The speed is the same across the Arctic Circle. That wouldn't be the case if the Earth were a rotating globe. I would like to see someone to use this method to show us that we really rotate on a moving globe. Shall we ever see such evidence? You can judge for yourself. Thanks.